We're continuing through exercise 3 on the inverse function handout. We still have part C to do here, so let's go ahead and do part C. We have the function f of x equals 5x plus 2 over 2x minus 3, and we want to find f inverse. And to find f inverse, we're going to follow our 4 steps. So let's go ahead and do that. First, we're going to replace f of x with y. That's really just to make the algebra easier to work with, because it's cumbersome to have an f of x in all these calculations. And now we got to solve for x. Some people like to switch x and y first and then solve for y. That's fine. If any of you talk to a tutor and they want you to switch variables first and then solve, you can. It's possible to interchange the steps 2 and 3, basically. All right, now solve for x. Now this is a bit of a challenging algebra problem because we got this messy fraction and we have x occurring in 2 different positions. I think we've seen at least one problem in this course so far where we had this issue where we wanted to take an expression where the variable occurred twice, and we wanted to write it in a way where the variable occurred just once. That's what we're going to do here. So my feeling is to solve for x, I want to clean up. Clean up means I'm going to multiply both sides by 2x minus 3 so that I don't have any fractions. So I'm going to take 2x minus 3 over 1 times that y over 1, and that's equal to 2x minus 3 over 1 times 5x plus 2 over 2x minus 3. 2x minus 3. And so it cancels out on the right, and we have just 5x plus 2. And on the left, I have 2x minus 3 times y. Now the 2x minus 3 has to go in parentheses. You can write the y in front or behind. Doesn't matter. I like to rewrite it with the y in front because I'm going to have to distribute. And so I want to do that. I also want to remove parentheses. And that will be accomplished if I distribute. 2xy minus 3y equals 5x plus 2. Now, our goal is to solve for x. That's, at the moment, we have an x here. We have an x term here. So to solve for x, get the terms with x on one side get the terms with no x on the other side. So the underlined terms in red are the x terms. I want those on the same side. The minus 3y to 2, those are the terms without x. I want those on the other side. Don't think, x and y, because y is going to end up on both sides. We're just focusing here on terms with x and terms that have no x. So I can subtract 5x from both sides. And I guess I'll write out the steps here. If you don't need this much detail, that's fine. 2xy minus 3y minus 5x equals, so now I have just 2 on the right? And I have a term with x here, a term with x here. So it's the minus 3y. I want to go away from the left-hand side. That means I have to add 3y to both sides. And there. And so we have 2xy minus 5x equals 2 plus 3y. And now I'm kind of happy where I'm at right now because I accomplished what I wrote up in red up there on the side. I got the terms with x on one side and the terms with no x on the other side. The whole point of doing this is I can now take this left-hand side and factor out an x. And I have x times 2y minus 5 in parentheses equals, I want to write this right-hand side as 3y plus 2. It doesn't really matter, but it's the same if I rearrange, put the y term first. So now when I factor out that x, I've accomplished this goal of getting this whole equation written with x occurring just once. So solving for x now, I'm just almost there. To isolate the x, I just need to divide both sides by what's in parentheses, the 2y minus 5. That's algebra. And so now I have x equals 3y plus 2 over 2y minus 5. And that's the hardest part of the problem. We're almost done. We're 99% of the way there. Because now we're just going to switch x and y. And again, if you prefer to switch x and y right at the very beginning, it's okay to do that. But then, of course, you're solving for y. You're not solving for x because their roles have been reversed. And I'm going to rewrite this with function notation, right? I'm going to write f inverse of x equals 3x plus 2 over 2x minus 5. Whoa. Oh. All right, so there's our inverse function. There's, where was our original function? There's c, our original function. And this is a good problem. So we want to make sure we know how to get through this process.